Okay, this video is all about z-scores. So in the PowerPoint lecture, I went over what a z-score is, but what we want to know about a z-score is there's really two things that you want to know is your mean and your standard deviation, and of course x, which we'll get to. So basically with the z-score, you're transforming x into z units. And we call this a z-score. And here's the formula. We're going to take x and we're going to subtract the mean. We're going to divide by the standard deviation. And keep in mind we're talking about, in this video, normally distributed data. So like a bell-shaped curve. Very important to know, z-scores. If they're negative, that means they're less than the mean. So if you had a curve here and this was your mean, if it's negative, it's going to be to the left. And if it's positive, it's going to be greater than, so it would be over here to the right. And if it's equal to the mean, then that z-score is going to be 0. Okay, moving on. Another thing, when you change the z-score, when you change it into the z-score, your mean is going to be 0. And your standard deviations are going to be, your first standard deviation is going to be 1, meaning that is 1 standard deviation from the mean. So we're changing these into different units. So let's look at how we would actually work a problem or start a problem off. So here, according to the American Consumer Satisfaction Index, airlines receive an American Satisfaction score of 73 in 2018. So we have an average, so that is our mean. Assume the satisfaction score is normally distributed, so that's a hint that this applies to z-scores. With the standard deviation of 13.5, what is the probability that a randomly selected respondent rated airline satisfaction with a score of less than 53? So 53 is going to be our x. Now in this video, we're not going to work the entire problem. We're going to start the problem off. To find the probability, you first have to change x into a z-score. So we would use our formula z equals x minus the mean over the standard deviation. So here, x, let me leave this up. So we said x is 53 and our mean is 73. And our standard deviation is 13.5. So let's calculate that together. 53 minus 73 would be negative 20. Divide that by 13.5. So z is negative 1.48. I'm going to round. Now let's look at what we have done with our information. So we started off with this bell-shaped curve because they told us it was normally distributed, and they told us our mean was 73, and then they told us our x was 53, so it would be somewhere over here. We'll just say, we know it's to the left because it's smaller. So what we did was, we're starting this problem, and to find probability you do have to change it into a z-score. But now we converted it into a z-score, so now 73, the mean has become 0. and the z-score is negative 1.48. And what that means is it's approximately negative 1.48 standard deviations away from the mean. If we were to take the mean and subtract one standard deviation, we would get 59.5. So 59.5 would be one standard deviation. And our number is 53, so it's a little bit over one standard deviation away from the mean. If you don't understand this part up here, that's okay. But I do want you to understand how we have taken the mean, and when we convert the mean into the z-score, the mean is always going to be 0. And then we're going to take our value and change it into the z-score, which is going to tell us how many standard deviations our number is from the mean. And then we're going to take this z-score in the next video, and I'm going to show you how to calculate the probability of less than the 53.